Reaction force calculation, non-concurrent force example. So here forces do not meet in one point. So, and also they're acting at different angles. They're not parallel. So you have to do some work to before we do the free body diagram. So the first thing, we have to resolve all these forces. If you resolve this 300 in the x direction, that's going to be 300 cosine 30 degree. So that is 260 pounds I found. And then we're going to resolve that along y direction, 300 sine 30 degree. That is 150 pounds. And then we have this 200 coming this way. I'm going to extend that 4 of, so that's 60. So you're going to resolve this way. That's going to be 200 cosine 60, which is 100 pounds. And then the vertical component going downwards, which would be 200 sine 60. So that's going to be 173 pounds. So you can resolve all these forces. Now we're going to remove the support at point A and point B. So point A, here we have the knife edge support. So we're going to remove that at point A. So if we remove that, then we'll have to balance this piece. So there is no support anymore. So we have to do the balancing force. So the reaction at A in the Y direction, and then reaction at A in the X direction. We also need to remove that component at the B, the connection at B or support at B. That's a rolling contact. So if we remove that, we will only have the upward direction force. So that's my point B. So it's going to be B Y. BY. So you got all these different reactions. So now to calculate the reaction forces, we simply take, like we did before, moment with respect to point A and sum everything to 0, counterclockwise moment positive, summation of all moment with respect to point A is equal to 0. So for this 200-pound force, this 200 cosine 60 will pass through A, so that will not produce any moment. However, the vertical component, which is 173, 200 sine 60, that is 173, will produce a clockwise moment with respect to A. So that's going to be a negative moment. So we're going to do, that will be negative 173 times 40 feet away from point A, and then plus, and then we have this 300 pounds. So the vertical component will cause a counterclockwise moment. So that will be a positive moment coming from that 150 pounds. And that is 40 plus 30 foot from point A. And the component, horizontal component, will pass through A. So that will not produce any moment. And then this 100-pound will cause a clockwise moment, which is negative. So 100 times, that is 170 feet. 40 plus 30 plus 100. So and then we have this reaction at B, which will cause a counterclockwise moment. It will try to rotate this piece counterclockwise with respect to A. Remember, you fixed A here, taking moment with A, about A. So reaction at B times the total distance would be 190. That's the total distance. Now, if we solve for RB, B at Y direction, I calculated that 71 pounds. Let me double check my number. again. So, yes. 71. And now we're going to do the same at point B. So we're going to do same thing. Counterclockwise positive, all moment with respect to point B, sum to 0, same thing. So for that 100-pound force, it will do a counterclockwise moment with respect to B. So that's positive 100 times 20 feet from B. And then this 150 vertical component will do a clockwise moment minus 150 times the distance is 20 plus 100, and then this downwards 200 sine 60, which is 173, will cause a counterclockwise moment, which is positive. So 173 times the 20 plus 100 plus 30, and then we have this RAY, which will do a clockwise moment with respect to B. So that's minus. So RAY 190. If you solve for RAY, that I found 53. So this is the two component reaction at point A and point B. So at A we found 53. At B we found 71. Now, if we sum these two together, they should be equal to all the resultant in y direction. So let's just check that. So summation of y, that is negative 173 coming from that 200 pounds, this guy, and then positive 150, this guy, 150, and then minus this 100, downward is negative. So if all this if you add all of these, I found minus 123 pound total external load in y direction downwards. These two, if you add, the reaction will be exactly 123. Now remember, we have three variables here. So we calculated our BY, reaction at B, reaction at A in the Y direction. However, we did not find RAY yet. So by taking moments, we couldn't find this guy. So what you have to do is basically summation of all X force is equal to 0. If you set that equation, that will give you that answer. So then it's going to be plus the reaction at, that's the positive X direction, and then this 200 cosine 60, which is 100 coming from that 200, that's going to be also positive, so positive 100. Then we have this 300 cosine 60, which is 260, again positive 260, and everything sum to 0. That's what we have in X direction. So then RAY would be actually minus RAX, RAX. Reaction at A in X direction should be minus 360. So as you can tell, all this X direction external force is acting in the right direction, that's positive. So there has to be about the exact same in the other direction to balance this force.